Have you ever heard of a blue zone? Well, a blue zone is an area where the average person that lives in that area has a higher life expectancy than a person in the general population. So, for example, in the US, we have Lima Linda, California, where the average person has a life expectancy that's about 10 years longer than the average American, which is about 78.2 years old. So, if you were to take a child living in Lima Linda and you were to ask them, what percentage of people do you think live to be 85? Now, that child has grown up in a society where most of the people live to be 85. So they would tell you, I don't know, 100%, and they would be wrong. So you might be thinking to yourself, well, that's a child. An adult wouldn't make the same type of mistake. And I would unfortunately have to tell you that you would also be wrong. Because based on the work of Daniel Kahneman and Amos Tversky, which won them the Nobel Prize in Economics, we know that people of all ages use mental shortcuts called heuristics in order to answer questions about the frequency of something occurring. So, for example, if somebody asks you, how often does something happen? We're usually not able to estimate that very well. And rather than actually answering the question, how often does this thing happen? We substitute it for the question of, how many examples can I think of? So if you were to ask somebody, what's the divorce rate? You would probably think of all of the married couples in your environment and think, well, how many divorced people do I know? None. So then I guess the divorce rate is zero. So that's a simplification, but essentially that is how our minds work. And so, what does this have to do with machine learning? What does this have to do with AI? So imagine that you are tasked with a very kind of basic machine learning project, which is a bank tells you to predict the people that are most likely to default on their loans. So you will probably be given massive amounts of data, lots and lots of features. Some of you might know them as variables. And you have to decide which ones you think are most valuable, right? And so for how are you going to make that decision? How are you going to decide which features are going to be most important in predicting whether someone's going to pay back their loan? You think about your own environment, you think about the world in general and think like, okay, so I guess income, right? The more money you make, the more likely it is that you're going to pay back your loan, your credit rating, things like that, right? Financial information. And if you thought that those were the biggest predictors of whether or not someone is likely to pay back their loan, there is research that says, again, you would be wrong. So, for example, there was a study that was done by Oded Metzer, Alain Lemire, and Michelle Herzenstein, which shows that actually the language that people use on their loan applications is a bigger predictor of whether or not they're going to pay back that loan than their credit rating or their income. So, the words that they found that are going to be most likely to project whether or not they're going to pay back their loans are words like debt free, lower interest rate, graduate, and things that are slightly more academic about financial information, right? And then the people who were least likely to pay back their loans used words like promise, will pay, hospital, thank you, and God. So you can hypothesize for yourself why those are the words that people use when they're less likely to pay back their loans. But it turned out that that language was a bigger predictor than maybe the variables that we would typically think of when we think of paying back bank loans. So I know that this is a simplified example, and I know that I'm immediately going to get a lot of responses that say, oh, but we have so many data science techniques to get around this problem and to look at feature importance and to try to figure out which features we use and which features we don't use, and et cetera, et cetera, et cetera. But the reason why I wanted to bring up this example specifically is because there really is a huge human component in choosing the features that we use for our machine learning models. Even the data that we collect has a huge human component in the availability heuristic, right? Maybe someone might have thought that the language in an application is not important at all and just not kept that data. And then you don't even have access to that data. So, what is the solution? I don't just want to tell you a problem without trying to suggest what I think should be done about this. Of course, we have our data science techniques, but I also encourage you to think more creatively, to think more outside the box, and think, well, maybe these very non obvious things that have nothing to do with my environment can also be important predictors or important features within my model. So tell me what you think. How would you handle avoiding the availability heuristic within your own modeling?